Okay, today we are going to be talking about finding the Maclaurin series of f of x is equal to e to the x and its radius of convergence. So to start this, we will need to write down the formula we are going to use to find the general formula of e to the x. So first, f of x is equal to summation and a is equal to 0. So n represents the number of derivatives you're going to take of the function being e to the x. So taking the derivative of e to the x will always get you e to the x. So 0th derivative of e to the x, just e to the x, the first, second, third, all e to the x. Just e to the x. And to find f of n multiplied by a is equal to 0. You will plug in 0 to the x here, and you will always get 1 for all of these. So for this formula, it will turn into 1 over n factorial multiplied by x to the n, because a is 0, x minus 0 to the n is just x to the n. And for this, this is the general formula for e to the x. Now we will also be finding the radius of convergence. To find this, we're going to have to use the ratio test. And so you find the limit as n goes to infinity of a sub n plus 1 all over a sub n. Absolute value signs around it. So for e to the x, we're going to use its general formula, which makes this the limit as n goes to infinity all over x to the n plus 1 all over n plus 1 factorial. This is going to be divided by x to the n all over n factorial. If you're asking why, if you don't get why we're dividing this and where this came from, this is the general formula. Whenever you multiply this on top, it's x to the n all over n factorial, which is where that comes in. And that's how you find, that's how you do the ratio test. So keep change flip this, and to keep change flip this, it will be the limit as n goes to infinity of x to the n plus 1 all over n plus 1 factorial multiplied by n factorial all over x to the n. So due to the laws of exponents, x to the n plus 1 is also just writing x to the n, x to the first multiplied together. And for this, turns into that. And for this, it is all over n plus 1 factorial. And you can also break that factorial up. And that factorial gets broken down into n plus 1 multiplied by n factorial, which gives you the same number. This is the same thing as this. It is just broken down. And you break this down so that whenever you multiply this by n factorial all over x to the n, they cancel out. This x to the n will cancel with that one. This n factorial will cancel with that one. And you are left with x to the first, which is just x over n plus 1. And you still got to find the limit of it. The limit as n goes to infinity. Absolute value signs, we got to keep those absolute value signs, carry everything over. The absolute value signs of x over n plus 1 you could take out an absolute value of x here if it confuses you. Absolute value of x multiplied by the limit as n goes to infinity, because we're just looking for in here. X does not matter. The limit as n goes to infinity. And it's bad to do arithmetic with infinity. College Board doesn't like it. Do not do it on your AP tests. But here just helps everything stay a little more organized and helps you understand. So it is 1, since you took out the absolute value of x, 1 over infinity plus 1. And that equates to 1 over infinity, and it'll just get closer and closer to 0, which means that the limit as n goes to infinity of 1 over infinity plus 1 is 0. And you will multiply that back. Do not forget about this factor. You will multiply that back by the absolute value of x, which is just 0 times the absolute value of x is still 0. Due to the ratio test, if the limit is less than 1, the series converges. And if the limit is greater than 1, the series diverges. So the radius of convergence will be infinity because the series converges due to the limit being less than 1. If the series converges, this is just an example of converging. The radius is going to be equal to infinity. So you can, if that confuses you, just forget about it. Just know that if the series converges of an e to the x function, you're finding the Maclaurin series of it. If the series converges, then the radius of convergence is infinity, will always be infinity. So we can just run through this quickly one more time to make sure everyone understands it. This formula, you will use it for e to the x, sine of x, cosine of x, everything you use a Maclaurin series for. In a Maclaurin series, you're just using it to find where the function is approximated at closest to x equals 0. And a Taylor series is what you will use to find where y is closest to 0. But for this series, we're finding where x is approximately 0 on a graph. So f of x is equal to summation infinity over, we will use this formula. F of x equals e of x. N is equal to, represents the number of derivatives you will take. If you keep taking the derivative of e to the x, you will get 1 every single time. So, if you get 1, a equals 0, this is a. F of n, f to the n multiplied by a is just 1 for each of these. So this is 1 over n factorial, and since a is equal to 0, x to the n multiplied by x to the n, you multiply through x to the n over n factorial, which is where we got this. And we used this, a sub n plus 1 all over a sub n is how we got this part. So if anyone has any questions, feel free to ask me. And this is the Maclaurin series of f of x is equal to e to the x and finding its radius of convergence.